Nimish Mukherjee. He's an associate professor in the Department of Computer Science and Engineering, IIT Kharagpur. He worked as an assistant professor in the same department for 4.5 years. Immediately before that, he was postdoctoral researcher in the complex system Lagrange Lab, ISI Foundation, Italy. He received his PhD from the Department of Computer Science and Engineering, IIT Kharagpur. His main research interests are in applying complex system approaches, mainly complex networks and agent-based simulations, to different problems in computer science, including human language evolutions and change, web, social media, information retrieval, and natural language processing. His publications are in top conferences like ACM, SIGKDD, ACM CIKM, ACM CSCW, ICWSM, ACL, EMLM, NLMLP, Calling, ACM IEEE, JCDL, and journals like PANAS, SCI reports, ACM, TKDD, ACM, CACM, IEEE, TKDE, IEEE, JSSC, Europhysics letters. He regularly serves on the program committee of various top conferences like IJCAI, EMNLP, Calling, IEEE, ACM, JCDL, IEEE, Globe, Com, and high-impact journals like PNAS, SCI reports like IEEE, TKDE, knowledge-based systems, advances in complex systems. He is the technical program committee chair of IEEE, ACM, ComSnex 2018, and the workshop chair of ACM Compute 2017. He also has a profile collaboration record with collaborators from different parts of the world, from both academia and industry. His work has received media attention from various agencies, including MIT Tech Review, BBC, Guardian. He received many awards: the Humboldt Fellowship for Experienced Researchers 2018 to 2021, Simmons Associate, ICTP, Italy, 2014-2019, Gandhian Young Technological Innovation Award 2017, IBM Faculty Award 2015, INSA Medal Young Scientist 2014, and INAE Young Engineering Award 2012, among many others. Sir will be talking on when the umpire is also a player, exposure bias towards private labels in e-commerce marketplaces. Now I will request Sir to please start the session.
Thank you very much. I hope I'm audible and
Yes, sir.
my screen is visible to everyone.
Yes, sir.
Thanks a lot for inviting me for this session, and also thanks a lot for the very long introduction. So without any further ado, I'll start off with the work that we are presently doing with Max Planck Institute for Software Systems. So where we are trying to study aspects of bias and fairness in machine learning and information retrieval systems that have become a very hot topic in current times. And I'll be talking a little bit about our current work in this area. So the team is like formed by Abhishek, who is the lead PhD student working on this project, Abhigyan, who is a postdoctoral researcher at Max Planck Software Systems, and two other faculty colleagues, Professor Saptarshi Ghosh from IIT Kharagpur and Professor Krishna Gumadi from Max Planck SWS. So this particular talk, so as I mentioned in the title itself, it's about e-commerce marketplaces, and this particular talk will take Amazon as a case study, and we will try to see the different dynamics and dynamical relationships that various entities on Amazon have with each other. So I guess the Amazon marketplace does not need any formal introduction. So it's one of the largest revenue earning companies in the world currently. So there are different physical categories uh, on Amazon, like fashion, electronics, digital services, etc., and even movies. And I guess many of you are already members of the Amazon Prime, and so the number of unique visitors per month on the Amazon website is roughly 200 million, and it's only increasing with the whole world going under lockdown. This number is only increasing, and there are around 2.2 million active sellers who sell various products on Amazon. So uh, the now one of the interesting research questions is that, how do customers browse through this huge number of products online? So there are 2.2 million sellers, and each of these sellers are selling hundreds of different products. The question is, like, how do you actually browse through all of these products? Even if you want to do it so manually, this is not possible, certainly. So there needs to be some sort of an automation. So one way of automating things, which is like, I guess, we use every other day, is searching the marketplace. So you search with various keywords, like the ones that I have also mentioned in this slide. So here the search term is battery. So uh, there are various categories of products that are actually displayed. So as you see, this particular battery item is a sponsored item. So Amazon categorizes this item as a sponsored item. We will come to this in little more details later. Whereas these are items that come out of the organic search. So they organically appear when you search with the term battery. Okay, so some items are actually coming from a list of sponsored items, while others are like coming organically from the database of all the battery items that are there in the Amazon repertoire. So the second thing is the recommendation system. So what is a recommendation system? So given a particular item, the system tries to recommend what other items are also suitable to the choice of the user. So here again, you see there are two different categories. One is the sponsored list. So basically, if you are, say, searching for a backpack, you get one list which are like, sponsored list of backpacks, and the other is more organic list. Like if you are searching for a particular backpack, you look at, Amazon looks at the history of what other users have found interest in while looking at that particular backpack, and that is what is being recommended. So I guess search and recommendation does not need any formal introduction. Most of you who have used this kind of platforms are aware of these utilities. However, what is important is this distinction, so which will actually form the premise of the entire study that I'm going to present in the following slides. So one is a sponsored set, and the other is a set which organically comes, which appears as a result of other customers viewing similar items. So in this particular talk, I'll be mostly focusing on the recommendation system. Search is also an interesting problem, but in this particular talk, I'll be mostly concentrating on the recommendation part. So the goal of traditional research in recommendation is that you should have you should try to promote customer satisfaction, and this is one of the primary goals. So the idea is that the customer should spend maximum time on the marketplace. Suppose if you are doing good on recommendation, then customers will be attracted to more and more products, and maybe they will also purchase more and more products, and that actually impacts the revenue of the marketplace. Whereas if the recommendations are improper, by improper I mean recommendations that are not relevant to your particular search, then you will be soon disengaged from the platform, and that has a direct, again, has a direct negative impact on the revenue. However, is it true, like the next question that immediately comes to our mind probably is that, is it true that customers are the only stakeholder of the marketplace? Not really, right? So there are other stakeholders, in fact, like who have, I would say, equal if not less stake in the marketplace, and they are the sellers, right? So the sellers have an equal stake in the marketplace. So while we are designing recommendation algorithms, are we really thinking about sellers, or are we really thinking about the products that the sellers are selling? Is it only the customer satisfaction that should come at the top of our head, or is it also that we need to look into the interests of the sellers? So this is the story that we are going to build up. So this also brings us to the main objective of the current study. So there are therefore two sides of what you call the fairness. Fairness means like the system being fair, or like being showing equality to everyone, every individual user of the platform. So there are again therefore two sides, since sellers also are an indistinguishable part of the platform. Therefore there are two sides of fairness. One is the customer fairness, where you want equal customer satisfaction for all the customers, whereas the other type of fairness is the multi-sided fairness, where apart from preserving customer satisfaction, you also try to give equal exposure to the sellers or producers. Suppose some sellers, so whenever you are searching with battery, if it is such that the marketplace is only recommending some sellers or putting up results from certain sellers, while it is like not showing results for certain other sellers, then that's not a very fair treatment. Okay, so the marketplace in that sense is not fair. So if you want to preserve the visibility or the exposure that a seller gets, then the marketplace has to design fair recommendation algorithms. So then the next question that comes is that, are we still missing something? So seems like there is one more key thing that we are missing. So why is the marketplace in itself important? You see, marketplace are organizations like Amazon, Flipkart, etc., Walmart, etc., right? So these are big marketplaces. So now the point here, the biggest point of contention here is that marketplace itself is also in the competition. Okay, so basically Amazon itself has started producing its own products like Amazon Basics, Amazon brand Solimo, etc. Also Amazon has this fulfillment services. So I guess anybody who have purchased from Amazon have seen this important tag like fulfilled by Amazon. So this means these are products that are actually the entire delivery is maintained by Amazon itself. So therefore you see if now the entire marketplace runner is also a person who is, or is also like impersonating as a seller. So this is where the problem comes in, and this is what justifies the title of my talk. So if the umpire himself becomes, you know, a part of the game and starts playing, then that's not a very good thing. So this is what is exactly happening in the various marketplaces. So this is not only in Amazon, this is also true in Flipkart, this is also true in Walmart and all other such big marketplaces. So if the marketplace that is supposed to, you know, host different sellers and attract customers to those sellers are themselves also playing as sellers, so therefore there will be a natural tendency of the marketplace to promote its own products, right? So this is a very intuitive thing that anybody can think of. And the question is, like, can one quantitatively, you know, study whether this is happening or not? And that is what actually lays the foundation of our current research. So as I said, Amazon itself, the marketplace itself, is in direct competition with other third party sellers and manufacturing brands on the platform. Okay. So before going into a little more details of the analysis that we have done, let us try to understand the marketplace and the different relationships of the entities on this marketplace, on an e-commerce platform. So there is the marketplace, which is Amazon itself. Okay, there are products, there are sellers, and there are customers. So the entities are sellers who sells different products, and then there is the other side of the coin, which are the customers. And the marketplace is kind of is supposed to be the host for the sellers, for the customers, and the products that the sellers sell. Now the for the Amazon in specific, there can be two types of customers, as I guess all of you are aware. It can be a prime customer or a non-prime customer. Sellers could be, you know, fulfilled by Amazon or Amazon affiliates. So these are also sellers which are, you know, like subsidiaries of Amazon, like Cloud10 India or Appareo India. These are both subsidiaries of Amazon, or fulfilled by the merchant. That is, these people are those who are not using the Amazon services for delivery, but using their own specific services for delivery. While on the product side, it could be a private label product, like the products that I have just now introduced, like Amazon Basics, Amazon Solimo, etc., and third party products. So these are products from other sellers. So this is more or less, in a nutshell, the structure of the marketplace. Now, there has been a lot of fairness concerns about the Amazon marketplace. So as I just now said, that Amazon is in direct contention with the other sellers on the platform, because Amazon itself, apart from being the marketplace, also acting as a seller in itself. And therefore, there are lot of allegations that already has come up in various news articles. Like, these are some of the examples, like Amazon changed algorithms in ways that boost its own products. So this is something like, you know, that I was trying to narrate a few slides back, that there will be a natural intention to steer their own products. Then Amazon is replacing product suggestions with ads and etc., etc. So there are lots and lots of um, um, such allegations. And in fact, the government itself in different countries have become serious about it. And in the US, there was a antitrust subcommittee which conducted a hearing of the different issues raised against the Amazon marketplace. If you just type in Google antitrust subcommittee hearings in the USA, Amazon responses, you will see a bunch of responses that the internal Amazon representative have put forward to the subcommittee. And you will see that many of these, answers are particularly hazy. So there is no quantification that has been done. Many of these answers are like very, very hazy and superficial. The same exercise has also been done by India in early 2019. And if you look at the FDI policies of the government of India, you will see that Amazon and Flipkart has been warned about certain different um, allegations that have been brought against them by different sellers. So in this work, we will try to do a little bit of quantification of this particular these these kind of allegations, whether these allegations are really there, whether Amazon is really making some discrimination among the sellers and things like that. So these are all, as I said, anecdotal evidences raising questions or concerns. Uh, However, they do not, give succinct quantitative answers. And the search that we are trying to make in this particular study is to bring forth certain quantitative justifications of whatever concerns that have been raised so far. So in a nutshell, we perform a systematic study of the sponsored recommendations on Amazon. We propose quantification of relative bias, and like we try to compare the organic recommendations with the sponsored recommendations. So sponsored recommendations, let me clarify here once and for all. So sponsored recommendations are recommendations which are paid. So there are sellers who pay Amazon specifically for sponsoring their items, okay, and showing their results at the top. And the organic recommendations are the recommendations that appear due to the natural behavioral history of a user. Okay, so this is the difference. So while the sponsored recommendations are mostly paid, the organic recommendations are mostly generated based on user behavior. So, and we will try to see what are the basic differences between sponsored recommendations and organic recommendations. So, in order to do this exercise, we had to do a massive data collection. So, the data collection actually comprise of, crawling the Amazon website. And as I told you that Amazon produces private level products, and we needed some categories where Amazon has different private level products, and so that those categories also should be, very generic. It should not be very, very specific, like say a very small cosmetic brand or something like that. Something that is very generic in nature, and at the same time something that has Amazon products, that is private level products. So we came up with two such categories. One is the backpack category. So backpack category has Amazon private label products, like as you see here, Amazon Basics. So this is an Amazon private product, and as you see, there is an Amazon logo also here. And along with that, it has in this category there are bags from other companies also, other sellers also. But this particular set of backpacks, which are manufactured by Amazon itself, are in direct competition with those other sellers. So backpack is one such category, which is pretty generic. And as I said, that there is this producer brand, and then there is this seller and fulfillment details. So this is actually fulfilled by Amazon itself, because it's its own private label product. And the other category that we chose is the battery category. Again, this is a very generic category, and it has again Amazon basics products like the one that you see here. It has Amazon logos like this, okay, and there are other products, other products from other sellers also in this category, with which the Amazon basic products are in direct competition. So this is a little bit of more details about the data. So there seems to be a noise. Yeah. So it's difficult to continue with the noise. It is very difficult to continue with the noise at the background. Thank you. Okay, so this is a little bit more details about the data. So we use a standard breadth first search crawler, and we start crawling using a set of seed products initially, and the recommendations and the metadata associated with it are collected. So in the backpack category, we collected 10,775 items, whereas in the battery category, we collected around 5,300 items. So both the organic and the sponsored recommendations, if you recall, are collected. So these are sponsored products and these are organic products. So both these recommendation lists are collected during the crawl. So a few important statistics, like only 1.5% of the total number of backpack products are private label products, a very small number. So out of 1245 distinct sellers, 62% availed fulfilled by Amazon facility. So all their travel logistics is handled by Amazon itself. Cloudtail India is the seller having the largest number of products, backpack products. So as I said, that Cloudtail India is actually a subsidiary of Amazon, and 19.8% of the products were sold by Amazon affiliates, either Cloudtail India or Appario Retail. Similarly, for the battery category, there are only 17 private label products out of 5,300 products in the battery category, and 1,068 distinct sellers are there, with 46% of whom actually availed fulfilled by Amazon facility. Cloudtail India again is the seller having the largest number of products, and 7% of the products were sold by the Amazon affiliates like Cloudtail and Appario. Now, then the question comes is, as I started off with, how to compare the extent of bias toward a special group of items in sponsored recommendation model relative to the organic model. Okay, so in order to do this, we need to first conceive a model. So how do we conceive a model? So what we do is we construct something called a related item network. Now this is a very important concept that I'll talk about, and we will be using this concept all through our analysis. So let us say that there are three items, A, B, C. Now for the item A, the things that are recommended on the page of item A are, say, B, C, and D. Things that are recommended are in the page of item B are, say, E, C, and F. And things that are recommended in the page of item C are, say, D, E, and F. So from this table on the left hand side, we construct a directed network like this. Okay, so the network shows that each node here is an item, okay, and a directed edge tells that there is a recommendation going from node B to node C. If there is a directed edge from node B to node C, then this means that there is a recommendation link going from node B to node C. In this way, you construct something called the related item network. Why related item? Because the underlying assumption of any recommendation algorithm is that the items B and C should be somehow related. So, for instance, if it is a backpack, I'm not going to, recommend a battery for a backpack. So, if it is a backpack, I'm going to recommend some other type of backpacks maybe. So, that's why there is this term related item. And if on the item page of B, there is a recommendation to C, we draw an edge, a directed edge like this from B to C. And in this way, the network gets constructed. So the left hand side table, when you construct the corresponding related item network, it will look like the right hand side graph. So the networks have different types of, such networks can be studied using different types of metrics like degree distribution, degree in degree of the different types of items, related rankings, core periphery analysis, reciprocity analysis. For the sake of uh, time, I'll be only talking about the in degree. So basically, just to give a brief idea of what is in degree, I guess all of you are aware. So here, in degree means the number of edges, directed edges that are incident on a particular node. That is, in this case, for the node C, there are two directed edges that are incident on C, and therefore the in degree of C is 2. Similarly, the in degree of E is 2, the in degree of B is 1, the in degree of F is 2, and so on and so forth. Now, say if some node has a large in degree, what does it mean? Say some node has an in degree 10, some node has an in degree 30. So it means that many items are recommending that item. Okay. So if you go back to the recommendation table, you would immediately be able to infer that if some node has a high in degree, it means that many other items are recommending that particular item on their page. Okay. So these are some of the interesting properties that we have observed when we compare the in degrees, okay, of the organic recommendation, organic related item network and the sponsored related item network. So you remember that we crawled the organic recommendation separately and the sponsored recommendation separately, right? So now, given this organic recommendations, we can construct an organic recommendation network, which we'll call the organic rain, and we can similarly construct a sponsored related item network, which we'll call the sponsored rain, right? And we are showing the results for the battery category. The same results are also observed for the backpack category. So some of the interesting observations is that, let us look at the in degree of the private label products. So as I said that there are 17 private label products in the battery category, right? In the battery category, there are only 17 private label products. But you see these 17 private label products, their in degree is 520 in the sponsored range. Whereas the average degree of any node is 11, they are sponsored, in the sponsored RIN, the in degree of the private level products is 520, which is like 500 times larger than any item, than any individual item randomly chosen in that network. So that means to these private level products, these 17 products, many other items on the Amazon marketplace, many other items actually recommend these private level products. So although they are 17, very small in number, many other products are recommending these 17 products. You see, that's why their um, in degree is so high. So anytime, as if anytime you search any item, any battery item, you are going to see one or more of the Amazon basic battery item in the recommendation list. So this is a clear sign of, clear initial sign of, discrimination or unfairness in the system. This is also true in the organic rain. It's 46, but here it is just 4 times. In the sponsored rains, it's 500 times. Okay, so uh, for the third party products which are not private level products, in the organic rain it is 11, which is also equal to the average in degree, whereas in the sponsored rain it's very low, it's 9. Okay, so similarly for the Amazon affiliated sellers like Cloudtail, Appareo, okay, these in degrees are very high. So it is 61 for the sponsored rain, and it is 18 for the organic rain. So 61, as you understand, is again a very large number, okay, compared to 11. Whereas the average in degree of the products that are sold by merchants on their own, these are not Amazon affiliates. They use their own logistics to, transfer materials. For them, the in degree is just 5. So there is a huge disparity between 61 and 5. So this is what I want to actually highlight in this slide. And all these results that you see here are statistically significant. So the next question is how to quantify the exposure induced due to different rains. So we have the sponsored rain and we have the organic rain. Can we somehow quantify the exposure induced due to the different rains? So for this, what we do is we use the popular random surfer model. So basically what it does is that as if you are standing on some item and you are randomly jumping on another item following one of its edges. So if I go back in that network example, suppose I am randomly standing on node C, I will now have to decide whether I can jump on some other node which are neighbors of C. So here we see two neighbors, E and D, and I can jump with equal probability on E or D. So the probability of jumping on E is half, the probability of jumping on D is another half. So suppose if C had in degree 3, then the probability of jumping to each of them would be 1/3. So this is what is the random surfer model. And you keep on jumping from one node to the other multiple times. So what will happen? So if some node has a very high in degree, you will keep on coming back to that node many times. Okay, so this is as if simulating the way people are searching items and following the recommendation links. So this random surfer model is kind of a simulation of the surfing of the recommendation items on the e-commerce platform. That's why we chose the random surfer model. So once you conduct this random surfing for a quite a long time, you find out the visit frequency, that is how many times a particular node has been visited by the random surfer. So if some node has a very high in degree, that means many other items are recommending that item, then that node will have a high visit frequency compared to some other node which has a low in degree and therefore will have a low visit frequency. Okay, so we do this random surfing on both the organic rain as well as the sponsored rain. So we call the exposure um, in the organic rain as the organic exposure, and it is denoted by EO. Similarly, we call the sponsored exposure as the exposure on the sponsored recommendation, sponsored related item network, or the sponsored RIN, and this is termed as or denoted as ES. Now the exposure bias, that is how different the organic exposure is from the sponsored exposure, is defined by the KL distance. This is a standard distance that you will find in the information retrieval literature. So this finds a distance metric between the between two distributions. So we find the KL distance between the exposure of ES, exposure ES, and exposure EO. That is the exposure given by the organic RIN and the exposure given by the sponsored RIN to the different items. So these visit frequencies that you have seen in the last slide, this forms the exposure distribution. So EO is the distribution of visit frequencies on the organic RIN. Similarly, ES is the distribution of the visit frequencies on the sponsored RIN, and you find the distance between the two distributions using the KL divergence or the KL distance, and this forms the metric for exposure bias. So now we will study that whether there is some distortion in the exposure for the sponsored recommendations. Okay, how the sponsored RIN is different in exposing certain items or certain sellers compared to the organic RIN. Let's see. So again, we will look into the results for the battery category, but the same results also hold for the backpack category. So as you see, there are some very interesting observations that we can make here. So on the x-axis, we write down the names of the different products, okay, and on the y-axis we write down the exposure values. Okay, this is the KL divergence that we have measured. And what do you see? You see that there are two brands that are largest, that are getting the largest exposure, and the largest among this brand in the sponsored RIN is Amazon itself. So Amazon is giving itself the largest exposure in the sponsored RIN. In the organic RIN also it is giving larger exposure to itself, but Duracell has a larger, even larger exposure than Amazon in the organic RIN. So that's why you understand, right? So people probably tend to prefer Duracell more than the Amazon, and therefore in the organic RIN, since it's based on the people's choice, that's why this is featuring as the most exposed brand. Whereas in the sponsored RIN, it's always, or it's almost always, that the private product, the private Amazon battery is getting the largest exposure. And actually the 17 private label products that we talked about in the very beginning, they account for 25% of the total exposure in the sponsored RIN. Similarly, if you look at the different brands, so the top brands are Power One, Panasonic, and Amazon. So once again, you see that Amazon is the largest brand. So Amazon is the largest product, Amazon is the largest brand, and in this particular result, it is more striking because 75% of the brands were underexposed. Okay, so they did not get their deserved exposure. So similarly for the sellers, so you see the two most important sellers are Cloudtel India and Appareo Retail. So these are the Amazon affiliates, as I told you, and they are subsidiaries of Amazon itself. Actually Amazon shares a large volume of company share with them. So these two are the most important or the most highly exposed sellers on the sponsored RIN as well as in the organic RIN. So even in the organic RIN, they are coming out to be some of the highly sponsored, sorry, highly exposed sellers. However, for the sponsored RINs, the numbers are too high, while all the others are severely underexposed. So you see, like any other seller is not even in competition. So that is, I mean, seems like that is a very unfair dynamics that is going on there. So it's like so there is one point of disclaimer here. Although we are talking about all this unfairness and discrimination, this might be unintentional. This might happen without even the knowledge of the Amazon engineering, that is the A9 company at the back, which actually does all the engineering stuffs. They might not be aware of these results. However, like even if they are unaware, we thought that a quantification or an auditing of the system is required to understand whether some sort of discrimination, some sort of bias is going on in the system. And this tells us, these results clearly gives us a quantitative evidence that there is strong signatures of bias present in especially the sponsored RINs. So I would end with this note that we observe that Amazon affiliates and Amazon private label brands seem to be, exorbitantly overexposed in the sponsored RIN as compared to the organic RIN. Sponsored RIN, it's like hugely overexposed, thus compromising the exposure of the um, other sellers or other products. Whereas in the organic RIN, we also see signatures of discrimination, but to a much lesser extent. So I would stop here and would love to take questions.
If anybody has any question, the questions are not coming in the chat box. So, so would you end your session? Because I think, will you go for any other topics?
So I thought this was the declared, this was the declared topic. I can show the results for the battery category if people are interested.
So you can show, because you have time. If you want to show, you can show.
Or if people are interested to listen to some other works of mine which we are doing on hate speech, some
Sure,
interesting.
Sure, sir.
So if the organizers are interested, then we can do that. But you have to give me a 5 minutes break and then we can start.
Okay, I'll just let you know.
Yeah.
Okay, sir, no problem.
Okay. So let's assemble back
Okay, okay.
in 5 minutes. I'll get my slides prepared.
Okay, sir.